All right, let's spend some time. Here we go. Happy day, happy day. I shouldn't be the only one. Happy day, happy day, happy day, happy day, happy day, Zoe, happy day. Happy day, happy day. And truthfully, this one is hard because it happens on the third Thursday of April. So it's not like specific to today. It's a kind of one of those holidays. Okay? Okay?
Why did it decide that?
What?
Who
Who decided yesterday was Take a Wild Guess Day? I don't know.
On the third Thursday of the month.
Well, it's National High Five Day. Yeah, exactly. This one, I have to do a full 100% credit to Mrs. Linsmeyer because she was paying attention to Big Cheese this morning. While she was making her breakfast, and she's like, "Hey, it's National High Five Day." I said, "Yep, it is." And then I had to go find it. Okay. All right. So we're actually going to start. So yes, I have this sheet, but tap the brakes on this sheet because that's not the first example we're going to do. I actually want you to go deep back into your notes. I don't really know how deep you need to go back into your own notes, but earlier this week we talked about Jordan Love throwing a football. Okay? Okay? So that's the one that I want to start with. Jordan Love throwing the football. We've already done this one. Okay? All right? So it should be already done for you. You should have some kind of sketches, etc. on this one. Our question was way back then. I mean, this probably was all of Tuesday. Okay? Right? So our question way back then was, how far can Jordan Love throw the football under these conditions? Okay? And so what we did is we graphed where we first came up with the blue parametric equation for this scenario. Then we graphed that parametric equation to find the parametric path of the ball. We determined then that we needed to find the x part of the point. And so we said option number one was we could trace, and we'd have to adjust that trace step to get as close as we can and all that stuff. But then we decided that that's not really going to be exact for us. Okay? Right? So fine, we're okay with that. Then we said our option number two was we can graph just the y of t function as a regular normal f of x function, and we can analyze that graph. We can find the zero, we can find the maximum height, we can do all of that fun stuff there. Okay? Then we can take that answer and sub option number one from option number two, bless you, is that we can plug that into x of t and find that answer. Okay? Sub option two of option two is we can take that answer and we can go right to that trace on our original graph. Okay? So we've got those. Today, we're going to come up with option number three. Okay? And option number three is, math is cool. Okay? Because we're going to do it algebraically. Okay? So we're going to utilize our graphing calculators, but we're not going to utilize the graphing part of our graphing calculator. We're just going to utilize the calculator part of our calculator. Okay? So option number thrice, what color? Well, let's go with the color of, we haven't really used purple. I know we use that purple there. Now we'll just go blue. We'll go blue for today. So option three is algebra. Okay? So I'm going to take my y of t function, which was negative 16t squared, plus 36 sine of 58 degrees, times t plus 6. I'm going to take that option, or that part, and what I'm going to do is I am going to solve that. We said how far we can throw the ball is where the ball is at what height. Jordan Love can throw a ball. How do we know how far Jordan Love can throw a ball? It's where the ball hits the ground, right? Okay. What's the height when the ball hits the ground? 0. So what am I going to do? I'm going to plug in 0 for, not for t. If I plug in 0 for t, I'm going to get 6, because that's where t equals 0. I'm going to plug in 0 for y of t. So I'm going to solve this equation. 0 equals negative 16t squared plus 36 sine of 58 degrees times t plus 6. Okay? What kind of an equation is that? It's what? It's quadratic. What are my choices to solve a quadratic equation? Factoring in quadratic formula, right? Okay? Because we can't use the graph, right? Said we couldn't use the graph. So which choice do you want to use? Factoring or the quadratic formula? And that's fine. Because in this case, it's really hard to find two numbers that multiply together to be 6 and add to be 36 sines of 58 degrees. Okay? So I wouldn't even begin to think about factoring. Okay? I would just go straight quadratic formula. Okay? So what is my A value then in the quadratic formula? Negative 16. What is my B value? 36 sines of 58 degrees. What is my C value? 6. Okay. Now, one quick thing on this one. Let's just refresh our memories as to what the quadratic formula actually is. So T is going to equal. Go for it.
Negative b plus or minus the square root of b squared minus 4ac divided by 2a.
All over 2a. Okay. If you have forgotten that, you need to rememorize that. Okay. Opposite of b plus minus square root of b squared minus 4ac all over 2a. Now, here is the coolness of cools. All right, so when we turn our calculators on and we get to a new document, we definitely want to be in a new document here now. Okay, so when we get to a new document, now I'm going to choose calculator because that's what I'm doing. We're not using the grapher, we're using the calculator this time. And what we're going to do is we're going to store things as A, as B, and as C. So I want negative 16 to store as A. And you got to hit enter. And then A is now locked in at negative 16. I want to store, what was it? 36 sines of 58. 36 sine of 58. Again, you got to make sure that we're in degrees. If you don't want to keep flipping back and forth from degrees to radians, you can always override the system by using the degree symbol, which is found underneath the pi key. Okay? And we want to store that as B. Mine just goes to exact, so that's why I switched it over. Okay? And we want 6 to be stored as C. Is everybody here so far? Okay. Now, we can't do plus or minus, so we have to do them individual. So what we're going to do, and I find this to be the easiest, but that's just me. I'm crazy like that. we can set up our fraction first by going control divide. If you go control divide, now you've got a fraction. The numerator of that fraction is going to be the opposite of b plus the square root of b squared minus 4 times a times c. And you have to put the multiplication sign between at least the a and the c. Otherwise, it won't recognize. Okay? And then on the bottom, you can just put 2a. Now, when I go to hit enter, I get that for a 0. What's wrong with that 0? Why is that bad? Exactly, that's a good question. Because it could be negative, it could not be negative. So can I ever have negative time? No. So that's what we found, right? We found this is a t-value. So we found a t-value of negative 0.1796. Okay? Now, let me save you some time. If I scroll up twice, whoop, tap the brakes. If I scroll up twice, notice how it highlights that. And then I hit enter, it copies and pastes it right into my next equation. What's the only part that I have to change on this one then? I got to change this to a subtraction. So I can scroll over, delete, and subtract there. And I get a t-value of 2.08773. To copy it,
Yeah.
scroll up.
Scroll then control.
Nope, scroll up, enter, and it pops it in there.
And then just enter.
And then just enter and it pops it in there. Yep. Okay? Which, if you'll notice, that was right here. Okay? So we found our t-value from before. Actually, I lied. Hold on. That was right. Come on, come back. Whoa, 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 whoa. That was. Come on. Grab the right one, Lynn. Come on. That was right there. Okay? Now, we still haven't answered the question yet, correct? Okay? So the question is, so this one, the top t-value doesn't work for us. Okay? Right? It'll work for us here in a minute, but it doesn't work for us. Okay? The bottom one is the time that the ball is in the air, correct? Okay? So what do we have to do with that one? Now we have to plug the one t-value.
When you put t equals 2.80 instead of
0.8. Oh, yep. Okay. Good eyes. That's my 5 day. Okay. So we need to plug that into x of t, right? Okay. So here now, again, I have a couple of options. My first option is I could store this value, 2.08773. I can store that value as my t. value. Okay? The other option is you could use the answer part. So like on your regular handheld, like the TI-30s, you on those, how you can use the ANS part, you have that option too. ANS on the graphers is control, and then the negative key is the ANS key. Okay? But then now you just have to type it in to the x of t function, which was 36 cosine of 58 degrees times now t. I have t stored as my time that it takes, and so that then is 39.8278 feet, which we found the other day to be 39.8278 feet. Okay? Right? If we needed to find the maximum height of the ball, what we would have to do, here, actually, let me expand on this blueness here. Come on. So if I need to find the maximum height, where is the maximum height of this ball going to be? Think back to your quadratic units. Maximum height of this ball, where will it happen? Where will it be? What? In between what? In between the two zeros, right? Okay? So you need to find the average okay? So you need to find the average of those two numbers to then find the t value that it's at, where that happens. So let's go back here. I know that t is my second one, my second zero, but I didn't ever save that first zero, but I can scroll back up until I get to it and type it in there. So I'm going to add those two numbers together, and then I'm going to divide by 2, because I need to take the average of those two numbers. So the t value for where the ball is at the maximum height is 0.954054. The t value for when the ball is at the maximum height is 0.954054. That's how they found that number. Then, to find the actual maximum height, what would you do with that number? Plug it into the y of x function. Yes, or y of t function, I should say. So now here, I would store this as something else, because you already got one as t. I'm going to go m, because it's right above the t, and then I know what I'm talking about. Okay? So now I would go negative 16 m squared plus 36 sine of 58 degrees times m plus 6. And that gives me that the ball is at a maximum height of 20.5635, which is 20.56, oops, step brace, which is 20.5635. Okay. Next week, Tuesday, you will have a question on your formative that you need to show all of this work. Now, you may be asking the question, how do we show all of this work on paper? Okay? That's where the other piece of paper that you picked up today comes into play. Yes. Not on the same problem though. Yes. You need to be an expert at both ways. Yes. Okay. So, if you notice on the piece of paper that you have, if you flip it over, it is identical. Okay? Right? So, you want to do the graphing way first, or do you want to do it algebraic first and then prove it with graphing? Either way, we're doing it by graphing and then proving it with algebra, or we're doing it with algebra and proving it with graphing. Algebra, prove it with graphing? Okay, so let's do this algebraically first. Okay? So here is an unnamed student was caught playing games on their cell phone during class, and as a result, their phone was sent hurling across the room. Phone traveled on a parabolic arc modeled by the given equations. Calculate the following. Okay? Question number 1 says, how far did the phone travel before it hit the floor and shattered into a million pieces? Question number 2, how far away was the phone when it reached its maximum height? Question number 3, what was the maximum height reached by the phone? Okay. Right. So we're doing this algebraically. Okay. So me personally, it's a brand new problem. So what I'm going to do on my calculator is I'm going to start a brand new dot. That way all of my variables are all cleared out. Everything is okay. Okay. Question number 1 says, how far did the phone travel before it shattered into a million pieces? Okay, so it traveled what is the height when it shatters into a million pieces? 0. So that means I set which one equal to 0? I set my y equation equal to 0. So I would show 0 equals negative 16 t squared plus 88 sines of 37.5 degrees t plus 6. How are we going to go about solving? Quadratic formula. So my a value is negative 16. So I'm going to write that. My b value is 88 sines of 37.5. And my c value is 6. Okay. I'm going to plug both of those, or all of those, all 3 of those. I'm going to plug those into t here equals the opposite of b plus minus square root of, I almost said 4b squared, but it's 5. Let's just restart this whole b squared minus 4ac all over 2a. Negative 16 was a. 88 sines of 37.5. 88 sines of 37.5 degrees is my b. And 6 is my c. Gives me that one. I'm going to store that one as S. I'm going to store that one as T. Okay. So 108,486. So I get a T value here of negative 108,486. 108,486. 345,667. And I get a T value of 3.45667. There. Yes? Okay. Next. So, answer to question number 1 is what? What is the answer to, oh wait, nope, I thought it was, how far away was it? Oh, nope, I thought, sorry, I read the question wrong. I thought it was how long was it in the air? We haven't answered question number 1 yet. Okay? So how are we going to answer question number 1? Plug which one? The last one, the positive one. Okay, so then that's going to be 88 cosine of 37.5 degrees times T. (241.328 feet). Wait, good hurl. (241.328). Yes? Okay. Question number 2. How far away was the phone when it reached its maximum height? How do I find that? Average my 2 T's. Okay. So for me, that is S plus T divided by 2. I get 1.67409. What do I do now? What are we trying to find? What if I plug it in for y of t? What is that going to give me? The maximum height, right? Okay. Question number 2 is asking what? how far away the maximum height is. So what am I going to do? Plug it into x of t first. Okay?
Wait, ours does say what.
What do you mean our problems are flipped?
Our number
Oh,
two,
like this,
or our
2 and
number 2
3
is the
is
maximum height.
Oh, okay. Okay, I see. Okay, gotcha. Okay, gotcha. I see. You flipped them around. Okay, so we'll do yours first then. That's fine. Sorry, I didn't know that. I blame Schmeling. Oh, I'm not gonna blame myself. National High Five Day. Self high five. Okay. So y of t is gonna be negative 16. So now it's gonna be 1.67409 squared plus 88 sines of 37.5 degrees times 1.67409 plus 6. On the calculator, that's going to be negative 16m squared plus 88 sines of 37.5 degrees times m plus 6. 50.8414. Right? Yep. Okay. So that was your number 2, my number 3. Okay? And then that's the maximum height that the phone gets, yes. Okay? Then it asks how far away was that maximum height. So that then is going to be an x of t. I get it's 116.877 feet away. What did I say? 116.877. Okay? Yes, you are going to be doing most of your work on the calculator, but that is the minimal amount of work that you need to show in order to get any points for this problem. Okay? Now, what I want you to do is I want you to flip that paper over, and now I want you to verify all of that by graphing. Okay? So you're doing the exact same problem on the back side. Here's all the answers on the front side. Now you're just solving it by graphing it. Go for it. So the 3 different graphs for the 3 different answers. Question number 1 was how far did the phone travel before it hit the floor and shattered into a million pieces? So that one, you have to first make this second graph. So this first graph was the parametric path of said phone. The second graph was the just the height, the parabolic height of the phone, and so it was in the air for 3.456674 seconds, which we also found in the last example when we did this exact same problem. So you have to plug that value in for x of t. So there's our 241.328 feet that the phone flew. So this one we can say feet, and this was answer to number 1, right there. Question number 2 and 3, depending on which one how you're looking at it on your paper or up here. How far away was the phone when it reached its maximum height? Okay, so then that one we have to, oops, I forgot to plug that in too. So that one we would have to plug in, we would have to plug this number in x of t, but then here is the answer to the maximum height for my number 3. But I forgot to plug in 167, 40, 94, 167, 40, 94. 1.674094. There's my 116.877. Okay. Good. Which should match everything on the other side of your paper. As that we found it. It's the exact same problem. Okay?
You suck in the birthday.
Awesome. So I got for you today.
Okay.